Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 3.2 Multiplying Polynomials. This is going to use some of the topics from the 3.1 Polynomials lesson that we talked about yesterday. Most specifically, it's going to talk about labeling our polynomials. All right, so let's get right into the lesson. The first thing we're going to do is we need to find each product, then classify the polynomial. When I have two binomials, just like I do in problem number 1, what we're going to do, it's called double distribution. Okay, that's the term that we use when we multiply two binomials like this. What it means is I'm going to take everything in the first set of parentheses and multiply it by everything in the second set of parentheses. Some of you have heard it known as FOIL, where we do first, outer, inner, last. It's basically, we just need to realize that we're going to multiply everything in the first set of parentheses by everything in the second set of parentheses. In some cases, we're going to have 3 sets of parentheses. We just need to know we need to multiply everything by everything. So what I do in order to make sure I take care of this is I'm going to draw arrows. So for problem number 1, I'm going to draw an arrow from the x to the x. X times x would get me x squared. Then I'm going to draw an arrow from the x to the 1. That would get me, keep the signs, or make sure we know what our signs are. So x times positive 1 would be positive x. Then it would be negative 3 times x, so negative 3x. And then negative 3 times 1 would get me negative 3. Once I have it completely multiplied together, I'm going to go ahead and combine like terms. So the first term is this x squared. Is there another x squared in the problem? There is not. So I'm going to leave that as x squared. Then I have positive x minus 3x. So positive x minus 3x would get me negative 2x. The last thing I have is this negative 3. There's nothing that can combine with, so I will just have negative 3. If you remember from yesterday or from the 3.1 lesson, we need to go ahead and classify our polynomial. In order to do that, I'm going to write down my leading coefficient. In this case, it would be the thing that's out front of my x squared, which is 1. I'm going to write down my degree, which is the highest exponent. So in this case, that would be 2. I'm going to have the number of terms. In this case, that would be 3 terms. So now we can name our polynomial. Remember, the name comes from the degree and the number of terms. So the degree is the second degree, so that is a quadratic. And the number of terms is 3, so that is a trinomial. So the name of this polynomial is a quadratic trinomial. All right, that's all review from yesterday's 3.1 lesson. If you do not remember those things, make sure that you have those out when you're working through your problems. The list of how we classify each polynomial. All right, on to problem number 2. Again, we're going to multiply everything by everything. So 2x times x would be 2x squared. 2x times 4 would be positive 8. Positive 8x. Positive 8x. 3 times x would get me positive 3x, and 3 times 4 would get me positive 12. You do not have to draw those arrows the entire time. I would continue to do that until you get a good feel for what you're doing. Once you have a feel for what you're doing, you don't always have to draw those arrows. I tend to still do it to this day, but that is your prerogative. So I'm going to go ahead and combine like terms. There's nothing that will combine with the x squared. I do have positive 8x and positive 3x. Those will combine to get me positive 11x, and then I have the positive 12, which will combine with nothing, so it's just positive 12. I am done at that point. I have distributed correctly. So my leading coefficient here is the number in front, which would be 2. My degree also would be 2. The number of terms, again, would be 3. So since my degree is 2, we want to name our polynomial. It would be a quadratic. And since I have 3 terms, it would be a trinomial. We do not want to try to name our polynomial until we have combine like terms. Once we've combined like terms, then I have the polynomial simplified as far as I can. That is when I can go ahead and name it. On to problem number 3. It's a little bit different here. I have a binomial times a trinomial. I'm going to treat it exactly the same way. I'm going to take everything from the first parenthesis and multiply it by everything from the second parenthesis. So the first thing I'm going to do is the x times x squared, which would be x cubed. The x times x, which would be positive x squared. The x times 1, which would be positive x. Then I'm going to have the negative 4 times x squared, so it would be negative 4x squared. Negative 4 times x would be negative 4x. And negative 4 times 1 would be negative 4. Now I need to go ahead and combine like terms. The first one I'm going to look at is the x cubed. Is there another x cubed in the problem? There is not, so it's just going to be x cubed. Then I'm going to have the x squared, and I'm going to combine that with all of the other x squareds. So I have negative 4x squared here. So positive x squared minus 4x squared would get me negative 3x squared. Then I have this positive x and this negative 4x. Well, positive x minus 4x would be negative 3x. Then I just have the negative 4. That will combine with nothing. So I am done there. Now I need to go ahead and classify my polynomial. The leading coefficient here would be 1. My degree is the largest exponent, so that would be 3. The number of terms, just count the number of terms. I have 1, 2, 3, 4 terms. So I can go ahead and name this now. Because my degree is 3, this would be a cubic. And because I have 4 or more terms, this would just be known as a polynomial. All right, so I have a cubic polynomial. On to problem number 4. X plus 3 cubed is the same thing as x plus 3 times x plus 3 times x plus 3. We're going to treat this exactly the same way as what we have done in every other problem. So everything that's inside each one of these parentheses must be multiplied by everything in every other set of parentheses. What I'm going to do is I'm going to start with the second 2 sets of parentheses. All right? So I'm going to take x times x, which would get me x squared. I'm going to take x times 3, which would be positive 3x. 3 times x is also positive 3x, and 3 times 3 would be 9. I'm going to go ahead and put that in a set of parentheses. I'm going to bring down my first set of parentheses because I haven't done anything with that yet. Go ahead and bring that down. The reason why I wanted to go ahead and work with the second 2 sets of parentheses is because when I draw my arrows now, it keeps it a little more organized than it did before. I could, in this second set of parentheses here, go ahead and combine like terms to get x squared plus 6x plus 9, but I can also do that at the end. It's not the end of the world. So I can do x times x squared, which would be x cubed, x times 3x, which would be positive 3x squared, x times 3x, which would be positive 3x squared, and x times 9, which would be positive 9x. Then I can take 3 times x squared, which is positive 3x squared. 3 times 3x would be 9x. Another 3 times 3x, which would be 9x. And 3 times 9, which would be positive 27. Now, again, I need to combine like terms. The first term, the largest degree, the largest exponent is the one I want to work with first because I want to write this in standard form. If I work with the largest exponent, then the next largest, and the next largest, it will automatically put it in standard form for me. So the first term is this x cubed. That will not combine with anything. Then I'm going to look at the 3x squared, and the 3x squared, and the 3x squared. So 3 plus 3 plus 3 would get me 9x squared. Now I'm going to go ahead and look at these positive 9x's. 9 plus 9 is 18, plus 9 is 27, so this would be plus 27x. And then I just have the positive 27 at the end. Just like I said before, if you work with the largest exponent, then you look at the next largest exponents, then you look at the next largest exponents, then you look at the constant at the end, you are going to go ahead and put them in standard form automatically. Now I can label, so my leading coefficient is 1. That is what is in front of the x cubed. My degree would be 3. The number of terms would be 1, 2, 3, 4. Oh, I'm sorry. Don't want n for number of terms. We use that for name, don't we? So this would be number of terms, 4. So now we can go ahead and name it. Since my degree is 3, this would be a cubic. And because my number of terms is 4, it would be a polynomial. So I have another cubic polynomial. On to number 5. Number 5. I'm going to have x minus 5 times x minus 5 times x minus 5, just like the last problem we worked through. Again, I'm going to work with the back 2 sets of parentheses first. So x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is positive 25. Bring down my x minus 5 in that set of parentheses. X times x squared would be x cubed. X times negative 5x would be negative 5x squared. Again, it would be negative 5x squared. And x times 25 would get me positive 25x. Negative 5 times x squared is another negative 5x squared. Negative 5 times negative 5x would be a positive 25x. Again, we would have a positive 25x. And 5 times 25 would be positive 125. All right. I'm sorry, this is negative 5 times 25, so that would be a negative 125. I apologize. That would be a negative 125. All right. So now, again, we need to combine like terms. So the highest exponent I have is x to the third, so I'm going to have x to the third first. Then I do negative 5x squared, negative 5x squared, negative 5x squared. So that would get me negative 15x squared. Negative 5 minus 5 is negative 15. Then I have positive 25x, positive 25x, and positive 25x. So positive 75x minus 125. Now I can go ahead and label my leading coefficients. There's nothing in front of my x cubed, so it'll be 1. The degree would be my highest exponent, which is 3. The number of terms, again, would be 4. So the name would be a cubic polynomial. Cubic polynomial. All right, on to number 6. We have two trinomials times each other. So in this case, we're going to do exactly the same thing we've done the rest of the time. So I'm going to go ahead and take x to the third times 3x squared. That would get me 3x to the fifth. Then I have x to the third times 6x, which would be positive 18x to the fourth. X to the third, I'm sorry, I messed that up. It's x to the third times 6x, so that would get me positive 6x to the fourth, my fault. X to the third times negative 5 would be negative 15x to the third. Then I have the x squared. So I've taken care of this x to the third. I no longer need it. So now I have 3x squared times everything. If you notice, I could keep making arrows, but it's just going to make a big mix-up. I'm going to have a bunch of arrows everywhere. It's going to kind of confuse us. So I'm just going to do 3x squared times 3x squared, so 9x to the fourth. 3x squared times 6x would get me positive 18x to the third. 3x squared times negative 5 would get me negative 15x squared. Then the 2 times everything. Positive 2 times 3x would get me positive 6x squared. 2 times positive 6x would get me positive 12x. 2 times negative 5 would get me negative 10. Now I need to combine like terms. So I'm going to do the 3x to the fifth. Is there another x to the fifth in the entire problem? There's not, so it's 3x to the fifth. I can get rid of that. Positive 6x to the fourth. Is there another x to the fourth? There is. It would be the 9x to the fourth. So this would get me positive 15x to the fourth. Okay. Then we go with the x to the thirds. I have negative 15x to the third and positive 18x to the third. I'm sorry, if you look at this negative 15x to the third, that came from our first term, x to the third times negative 5. So that should not be negative 15. I apologize. That should be negative 5x to the third. Negative 5x to the third. So I have negative 5x to the third and positive 18x to the third. That would get me positive 13x to the third. So the x to the thirds are gone now. What's the next highest exponent? Well, it would be x squared. So I have negative 15x squared plus 6x squared, which would get me negative 9x squared. Then I just have my x's, so positive 12x and negative 10. Whoops, negative 10. All right. Now that I have it, all the terms combined together, it is in standard form. I can go ahead and characterize, classify. So I have my leading coefficient of 3. I have my degree of 5. The number of terms, just count each term. The number of terms would be 1, 2, 3, 4, 5, 6. So there are 6 terms here. So the name. We have the name now. My degree is to the 5th. If we remember from yesterday, when your degree is to the 5th, it would be a quintic. Quintic. Anything 4 terms or higher would get me a polynomial. So it's a quintic polynomial. All right. On to number 7. Again, we have 2 trinomials times each other. So we just need to multiply each term in the first set of parentheses by each term in the second set of parentheses. So I'm going to take 30 times x, which would get me 30x. I'm going to take 30 times negative 15, which would get me negative 450. I'm going to take 30 times negative x squared, which would be negative 30x squared. Then I'm going to take the 30 is done. I don't have to worry about the 30 anymore. Now I'm going to take x to the cube times x, which would be positive x to the 4th, x to the 3rd, x cubed, minus 15 would be negative 15x to the 3rd. X cubed times negative x squared would be negative x to the 5th. So the x to the 3rd is now done. Now I have x squared times x, which would get me positive x to the 3rd. X squared times negative 15 would be negative 15x squared. X squared times negative x squared would get me negative x to the 4th. Those will not cancel. Those will only cancel if I was adding or subtracting those terms. Now I need to go ahead and combine like terms. Again, the first thing I want to look for is the largest exponent. So 30x, x is not going to be my largest exponent, is it? X to the 1st. X to the 2nd is not bigger than x to the 4th. So right now, x to the 4th is the largest exponent I've found. X to the 3rd is smaller, so I'm still good. X to the 5th is actually larger than x to the 4th. So in this case, that is going to be my largest exponent. So I need to keep its sign. This is going to be negative x to the 5th. Negative x to the 5th out front. So the x to the 5th is done. Now I'm going to look for an x to the 4th. I have positive x to the 4th and negative x to the 4th. Those are actually just going to go ahead and cancel. Now I'm looking for an x to the 3rd. I have a negative 15x to the 3rd and a positive x to the 3rd. So that's going to get me negative 14x to the 3rd. Looking for x squareds now. I have negative 30x squared and negative 15x squared. So it would be negative 45x squared. Now I have a positive x, so positive 30x and a negative 450. So we have combined like terms, and because we went from the largest exponent to the smallest exponent, we are in standard form, and we can go ahead and classify our polynomial. So my leading coefficient in this case would be negative 1. My degree would be the 5th degree. The number of terms, it would be 1, 2, 3, 4, 5 terms. So the name of this polynomial would be, again, a quintic polynomial because I have more than 4 terms. I have more than 4 terms. So I have a quintic polynomial. On to number 8, we have a binomial times a trinomial. Again, it's the exact same thought process. I'm going to go ahead and take the 2x times 3x squared, which would get me 6x to the 3rd. 2x times x, which would get me positive 2x squared. 2x times negative 1 would get me negative 2x. And I have 1 times 3x, which would be positive 3x squared. 1 times x would be positive x. And 1 times negative 1 would be negative 1. All I have to do now is combine like terms. Use your largest exponent first. My largest exponent is x to the third, so it would be 6x to the third. That's done. I have a positive 2x squared and a positive 3x squared, so that would be positive 5x squared. I have a negative 2x and a positive x, so that would be negative x and negative 1. So 6x to the third plus 5x squared minus x minus 1. The leading coefficient here would be 6. My degree would be 3. The number of terms would be 1, 2, 3, 4. So the name of this polynomial would be a cubic polynomial. On to the last problem. This one's a bit more tricky. This one is a bit more tricky because I have C's and D's. Now, when I multiply, I'm only going to add the exponents if they have the same variable. So looking at negative 4c squared d to the third times 5c d to the second. I'm going to take the negative 4 times the 5. That would get me negative 20. I'm going to take the c squared times the c. So that would get me c to the third. I'm going to take the d to the third times the d squared, so I'd have d to the fifth. All right? That's all you have to do when you're multiplying those. Don't make it any more difficult than that. If the numbers will multiply by each other, and each variable that is the same will multiply by each other. So I'm going to take the negative 4 c squared d to the third times 3c squared d. Negative 4 times 3 would be negative 12. C squared times c squared would get me c to the fourth. D to the third times d would get me d to the fourth. Now the question is, how do I write this in standard form? I always want my largest exponent to go in the front. I don't care if the c has the largest exponent or the d has the largest exponent. In this case, if you just look for the largest exponent would be the 5. So this d to the fifth is in fact my largest exponent, which means that right now I already have my problem written in standard form. So I can classify. My leading coefficient would be negative 20. Okay. My degree would be the largest exponent again, so my degree would be to the fifth. My number of terms, I only have 2. So now I can name my polynomial. Well, since my degree is to the fifth, it would be a quintic. And the number of terms is 2. It would be a binomial, bi being like a bicycle. Okay, a bicycle has 2 wheels. The number of terms is 2, so it's a binomial. On to 10. I have xy times 5x squared plus 8x minus 7. So xy. Remember what I just said on problem number 9. I'm going to have 1 times 5, which is 5. I'm going to have x times x squared, which is x to the third. I'm going to have y times, there isn't another y there, so it's just going to stay a y. Then I have xy times 8x, so this would be 8 times 1, which is 8. X times x is x squared. Y times basically 1 is going to be y. All right, and then on to the last one, negative 7 times 1 would be negative 7. X times, there's not another x there, so it's just going to be x and y because there's not another y there. So now, is this in standard form? My largest degree is in the front. My largest exponent's in the front, so it is in standard form. So my leading coefficient will be 5. My degree will be 3. My number of terms will be 3. So my name would be a cubic trinomial. Trinomial like a tricycle. There are 3 wheels on a tricycle, so it is a trinomial. That is the end of our lesson. The most important things here to remember are how to multiply the different polynomials. You want to multiply each term from the first set of parentheses by each term in every other set of parentheses, and how to classify, which actually is review from lesson 3.1. Thank you very much for watching my video. Make sure if you have any questions, you bring them to me tomorrow, and have a great day.